Hello viewers, in the last class we studied about floating point representation and character encoding. I hope it is clear to you. Today we are going to study a new topic called input output organization. In it we will be studying peripheral devices and input output interfaces. Besides this, we will also learn various modes of data transfer. Let us begin with peripheral devices. Peripheral devices are devices that attach to the computer and are external to the case. Sometimes they are called I/O devices, indicating input output devices. These devices input data into the computer and output data from the computer. There are three different types of peripherals: input, used to interact with or send data to the computer. The second one is output, which provides output to the user from the computer, and the third one is storage, which stores data processed by the computer. Some of these input output devices are very common and some are used rarely. The common ones are the keyboard, the monitor, the printer and the mouse. Other peripherals are the microphone, speakers, webcam, the flatbed scanner, USB flash drives, external hard drives and specialized devices. Let us discuss some of the peripheral devices one by one, beginning with the keyboard. The keyboard is an input device that allows you to enter alphanumeric data into the computer. It also allows you to edit, correct, change or modify existing data. Then comes monitor. The monitor is an output device that displays data in a pre-programmed manner. This allows you to evaluate the data and perform an appropriate action on it. The data can be text, video, pictures, graphics or anything else you can think of. Now next is printer. The printer is an output device that permits the creating of a hard copy of textual, photographic or graphic data. One of the most common devices people buy for their computer is a printer. The most common type of printer for the home user is a color inkjet. They tend to be cheap and produce fairly good image and text quality. Another common type of printer is a laser printer. These are most commonly used by businesses that need to print larger quantities of documents and need better quality and a faster print speed. Then we have a computer mouse. The computer mouse is an input device that allows you to point to items on the monitor in order to perform pre-programmed functions. It can be used with all sorts of data, text, video, pictures, graphics, etc. Sometimes the mouse is also called a pointing device. Next is the microphone. The computer microphone is an input device that allows you to enter speech as data, thus allowing you to record this data or transmit it to the others over the internet. The other commonly used device is speaker. The computer speaker is an output device that allows you to hear pre-recorded sound or the sound coming over the internet. Sound is produced by the sound card within your computer. There are many types of sound cards, but even the best model won't sound good if you have low quality speakers. In fact, the speakers make more of a difference than the sound card does when it comes to the sound quality. Then we have a webcam. The webcam is an input device that permits the input of photographic or video data into the computer, the purpose of which is for recording or transmitting video data over the internet. Webcams are mostly commonly used to make video calls to friends and family over the internet using a broadband connection and instant messenger software. With a webcam on both ends of the conversation, you can talk to and see the person on the other end just like you were there. The quality of the image and sound will depend on your connection speed and quality of your webcam. Next is a scanner. The flatbed scanner is an input device allowing high quality photographic, textual and graphic data to be entered into the computer. Scanners are used to scan photographs and documents into the computer. After you scan in these items, you can then use additional software to edit them or do other things such as email or back them up. There is a software called optical character recognition (OCR) that will allow you to edit the text on documents that you have just scanned in. Then we have a flash drive. The USB flash drive is an input and an output device. It is used mainly as a storage device to transport data from one computer to another. Back in the old days, when you wanted to copy some files from one computer to another, you used a floppy disk. But floppies don't hold much data and became obsolete after recordable CDs became common. But apparently CDRs were too much work. So now there are USB flash drives. These small drives are capable of holding much more information than CDRs. The flash drives can hold 4 GB or even more amount of data as compared to CDRs, whose capacity is around 700 MB. Plus, they are easier and faster than burning CDs. All you do is copy the data over to the flash drive like it was a floppy disk or another hard drive, and then insert the drive into the computer and copy the data over. The drives can be written to and erased many times over, so you don't need to worry about having to replace the drive unless it breaks. Next is the external hard drive. The external hard drive is both an input device and an output device. It is used as an output device to copy and archive data. Also, it is used as an input device to retrieve and restore data. More than one external hard drives can be added to the computer. If you have a need to back up your data, then an external hard drive is a good way to do it. It can hold huge amounts of data and can be easily transferred from one computer to another. There is the option of backing up to CD or DVD, but external hard drives can hold much more data and are rewritable and act just like a hard drive in your system. Once you do your backup, you can take it with you or store it offsite in a safe place just in case something happens to your computer. Many people use them as additional storage rather than installing another internal hard drive inside the computer. They typically connect to your computer via USB port or sometimes even a 5-wire port. Then comes projectors. Projectors can be used to display the image from your computer onto a movie screen for other people to view. This is used most often in conference rooms for meetings where everyone needs to see what's going on. For the home user, this can be used for the slideshows or showing home movies right off your computer. The downside to using a PC projector is that they tend to be very expensive. With this, our peripheral devices part is over. Now, we will discuss input-output interfaces. Input-output interface provides a method for transferring information between internal storage and external input-output devices. Peripherals connected to a computer need special communication links for interfacing them with the central processing unit. The purpose of the communication link is to resolve the differences that exist between the central processing unit and each peripheral. The major differences are: number 1, peripherals are electromechanical and electromagnetic devices, and their manner of operation is different from the operation of the CPU and memory, which are electronic devices. Therefore, a conversion of signal values may be required. Second is, the data transfer rate of peripherals is usually slower than the transfer rate of the CPU, and consequently a synchronization mechanism may be needed. Third point is, data codes and formats in peripherals differ from the word format in the CPU and memory. And fourth is, the operating modes of peripherals are different from each other, and each must be controlled so as not to disturb the operation of other peripherals connected to the CPU. To resolve these differences, computer systems include special hardware components between the CPU and peripherals to supervise and synchronize all input and output transfers. These components are called interface units because they interface between the processor bus and the peripheral device. It is shown in the figure. Here, data, address and control are the 3 buses which are connected to the interfaces, which are further connected to the peripheral devices. To communicate with a particular device, the processor places a device address on address lines. Each interface decodes the address, and control received from the input output bus interprets it for peripheral and provides signals for the peripheral controller. The interface also synchronizes the data flow and supervises the transfer between peripheral and the processor. Each peripheral has its own controller. For example, the printer controller controls the paper motion, the print timing, etc. The control lines are used for transmitting input-output commands. The commands are: number 1, control command. A control command is issued to activate the peripheral and to inform it what to do. Number 2, status command. A status command is used to test various status conditions in the interface and the peripheral. And number 3 is output data command. A data output command causes the interface to respond by transferring data from the bus into one of its registers. And the 4th one is input data command. The data input command is the opposite of the data output. In this case, the interface receives one item of data from the peripheral and places it in its buffer register. As far as data lines are concerned, the data travels between the central processing unit and peripherals on these lines. Now, let us see what are the major functions of an input output interface. Number 1 is control and timing, number 2 CPU communication, and then number 3 is device communication, number 4 is data buffering, number 5 is error detection. Let us understand these functions with the help of an example. In control and timing, coordination of traffic between internal resources and external devices is done. Here, first of all, processor interrogates status of input output module, which we can call CPU communication. The module returns device status. Device indicates whether it is ready to transmit the data or not, which we can call device communication. If it is ready, the processor requests the data transfer by means of a command to the module. Based on the command, and input output module obtains a byte of data from the device, which is nothing but data buffering. The data is transferred to the processor, and if there is any error, it is conveyed to the device, which we can call as error detection. This is how it is done. This operation typically requires one or more bus arbitrations. I hope input-output interfaces and their functionality is now clear to you. Now, we will discuss modes of data transfer. Transfer of data is required between CPU and peripherals or memory, or sometimes between any two devices or units of the computer system. To transfer a data from one unit to another one should be sure that both units have proper connection and at the time of data transfer, the receiving unit is not busy. This data transfer with the computer is internal operation. All the internal operations in a digital system are synchronized by means of clock pulses supplied by a common clock pulse generator. The data transfer can be either synchronous or asynchronous. When both the transmitting and receiving units use same clock pulse, then such a data transfer is called synchronous process. On the other hand, if there is no concept of clock pulses and the sender operates at different moment than the receiver, then such a data transfer is called asynchronous data transfer. The data transfer can be handled by various modes. Some of the modes use CPU as an intermediate path, others transfer the data directly to and from the memory unit, and this can be handled by three ways. Number one is by using programmed input output, number two interrupt initiated input output, and number three direct memory access DMA. Now let us discuss programmed input output mode. In this mode of data transfer, the operations are the results of input output instructions which are a part of computer program. Each data transfer is initiated by an instruction in the program. Normally, the transfer is from a CPU register to peripheral device or vice versa. Once the data is initiated, the CPU starts monitoring the interface to see when next transfer can be made. The instructions of the program keep close tabs on everything that takes place in the interface unit and the input output devices. In this technique, CPU is responsible for executing data from the memory for output and storing data in the memory for the execution of programmed input output as shown in the flow chart. The main drawback of program initiated input output is that the CPU has to monitor the units all the times when the program is executing. Thus, the CPU stays in a program loop until the input output unit indicates that it is ready for the data transfer. This is a time consuming process and the CPU time is wasted a lot in keeping an eye on the execution of the program. To remove this problem, an interrupt facility and special commands are used. Now next is interrupt initiated input output. In this method, an interrupt facility or interrupt command is used to inform the device about the start and end of the transfer. In the meantime, the CPU executes other program. When the interface determines that the device is ready for the data transfer, it generates an interrupt request and sends it to the computer. When the CPU receives such a signal, it temporarily stops the execution of the program and branches to a service program to process the input output transfer, and after completing it returns back to the task what it was originally performing. The execution process of interrupt initiated input output is represented in the flow chart. We have two types of interrupt initiated input output. The first one is vectored interrupt and the second one is non-vectored interrupt. In vectored interrupt, the source that interrupts supplies the branch information to the computer. This information is called the interrupt vector, whereas in a non-vectored interrupt, the branch address is assigned to a fixed location in the memory. So, with this interrupt initiated input output is over, and this is also the end of the lecture. Concluding our lecture, we have learnt what is a peripheral device and what are its applications. We also learnt what are input output interfaces and why do we need them. Apart from this, we discussed how data flow between central processing unit and the peripheral devices takes place. At the end, we learnt various modes of transfer like programmed input output mode and interrupt driven input output mode. The third mode of transfer, that is DMA, also called direct memory address, will be discussed in the next lecture. Thank you. Have a good day.